Welcome. We want to look at the relationship between heat of solution, hydration, and lattice energy. But before we look at the relationship between these three, we need first to remember and understand some concepts that we learned in the topic of energy changes. That is the bond breaking and the bond formation. You need first to understand what is energy released during bond breaking or energy is absorbed. Is bond breaking exothermic or endothermic? Is bond formation endothermic or exothermic? That's the first concept I would want to remind you. The next one is the energy levels. How does the energy level of an exothermic reaction look like? How does the energy level of an endothermic reaction look like? A quick reminder is that in an endothermic reaction, the system absorbs heat energy from the surrounding. Therefore, the products have a higher energy compared to the reactants. Very important. So if the products have a higher energy, then we expect the reactants to be down, because suppose this one is 10, and then the products must be something 20. The energy is higher for the products. Remember that. So this one is for an endothermic. So always remember that for endothermic reaction, the products have higher energy and the reactants have lower energy. You know that, so it is a reminder, because this is what is important for you to understand the relationship between heat of solution, hydration, and lattice energy. In an exothermic reaction, heat is lost from the system. We know that. I know you know that. The products therefore have lower energy content compared to reactants. Are very important. So this one will help us to know the reaction. The overall reaction in exothermic is negative, because you see when the product minus this, it is 10 minus 20, the answer is going to be negative 10. Therefore, that's why in an exothermic reaction, the products are below the reactants. Let me repeat that. In an exothermic reaction, and you are drawing an energy level, the products must be below the reactants. The reactants should have higher energy content, and the product has lower energy content. That's another quick reminder. Next one, we want to remind ourselves about bond breaking and the bond formation. So bond breaking and the bond formation involve energy changes in the substance involved. For example, when methane reacts with chlorine, like you can see in this equation, so for the reaction to occur, the covalent bonds in both methane and chlorine must be broken to obtain separate atoms. So for chlorine to react with methane, this bond in methane must break like this: hydrogen, 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 hydrogen. So this is bond breaking. Chlorine must break like this: chlorine, chlorine. So this is what we call bond breaking. So to obtain chlorine, for the reaction to occur, the covalent bonds in both methane and chlorine must be broken to obtain separate atoms. Energy is required to break these bonds. Thus, bond breaking is an endothermic process. Please mark that. Bond breaking is an endothermic process. Once the bonds are broken, the atoms rearrange themselves and a new bonds are formed. And the new bonds are formed in the products. Very correct. In the process of bond formation, energy is given out. Therefore, bond formation is an exothermic process. Very, very, very critical for you to understand that. So what we were reminding ourselves is that bond breaking is an endothermic process. Bond formation is an exothermic process. Very important. Back to our business of the day, relationship between heat of solution, hydration, and lattice energy. So let us define what is lattice energy. Lattice energy is the energy change that occurs when 1 mole of an ionic compound is formed from its constituent ions in gaseous form. Now this is an ionic bond plus another ion here. This is an ion plus another ion forming sodium chloride. So this is an ion and this is an ion. They are combining to form sodium chloride. So is it bond breaking or bond formation? This one is bond formation. We have said that bond formation is an exothermic. Therefore, lattice energy involves bond forming because the cations here in gaseous form, they are combining to form sodium chloride, and that's why the lattice energy here is negative, because bond formation is exothermic. Therefore, the overall heat change is negative. So it is important to know what is lattice energy. It is the energy change that occurs when 1 mole of an ionic compound is formed from its constituent ions in gaseous state. Lattice energy is negative, but has a negative value because the reaction is exothermic. Lattice energy is denoted by this. So we denote lattice energy by this heat change, lat. So lattice energy of sodium is negative 77 kilojoules per mole. So when sodium chloride is formed from the ion, from its constituent ions which are in gaseous form or state, then negative 776 kilojoules the heat is released. So 776 heat is released. To release, it is exothermic. Now this is where our concern is. Now we have formed sodium chloride, which is an ionic compound. So we want now to add water to sodium chloride. So that's where our concern is, dissolving sodium chloride in water. So when an ionic substance dissolves in water, energy equivalent to the lattice energy is absorbed. For example, when sodium chloride is dissolved in water, the ionic solid dissolves in 2 stages. So it doesn't just dissolve. When sodium chloride is dissolved in water, it dissolves in 2 stages. Stage 1, the solid sodium chloride is separated into its gaseous ions, meaning that sodium chloride is broken down. That is bond break. The bonds are broken like this. So sodium chloride breaks like this, gaseous plus chlorine ion, which is gaseous. So the solid sodium chloride is separated into its gaseous ion. So the bonds are broken. That's why it was important for you to remember bond breaking. So if bonds are broken, is that process endothermic or exothermic? So bond breaking is endothermic, right? So the process is endothermic because we are breaking the bonds. Sodium chloride is breaking to form sodium ions, so the bonds are broken. Therefore, the process is endothermic. So the amount of energy absorbed is equal to lattice energy, but has a positive sign, right? The positive sign, now remember lattice energy has a negative sign because it is bond formation. But now dissolving sodium chloride in water, it is bond breaking. The bonds are broken, therefore it is the opposite. It is the reverse of lattice. Therefore the reaction is endothermic. The amount of energy absorbed is equal to lattice energy but has a positive sign. The lattice energy is given a positive value because bond breaking is an endothermic process. Very, very important. This is called reverse of lattice energy. Remember, lattice energy, it was the ions in gaseous form forming sodium chloride. So when you go this way, you form bonds of sodium chloride, you form, and the lattice energy is negative. But now sodium chloride is dissolved in water. It breaks fast. It is separated to its ions in gaseous. So sodium ion in gaseous form, chloride ions in gaseous form. So this reaction, this process is endothermic, and that's why the heat change is, or the enthalpy change is positive 776. But you realize that this reaction, it is the opposite of the lattice, because lattice is negative and reverse lattice is positive. The energy is the same. Very important. So the bonds are broken, and then the heat that is absorbed is 776 kilojoules per mole. So that is stage 1. What happens in stage 2? Stage 2. In this stage, the sodium and the chloride ions, now the one after bond breaking, we have the sodium and the chloride ions, which are in gaseous form, get surrounded by several water molecules. The water molecules surrounding the sodium ions arrange themselves in such a way that the partially negative oxygen is attracted to the positive sodium ion, and the partially positive hydrogen is attracted to the negative chloride ions, and the ions become hydrated. Now we are now talking about the second term, hydration. So now these ions, the sodium ions, which are in gaseous form, and the chloride ions, which are in gaseous form, are surrounded with water molecules, and they become hydrated. So they are surrounded in such a way that the sodium ion, which is positively charged, arranges itself such a way it is attracted to the oxygen, which is partially negative. Remember, oxygen is negative and the sodium is positive, so these charges, they attract to one another. So you can see it is the oxygen, sodium, oxygen, sodium. The chloride ion is surrounded by the partially positive hydrogen. So hydrogen is positive and the chloride ion is negatively charged. Therefore, the water surrounds the sodium ions in this way, and then the ions becomes hydrated. So when something becomes hydrated, if you jump into a swimming pool, you go deep into the water, you are covered by water, you become hydrated. So these ions now covered by water, they become hydrated. So now we have talked about the hydrated, the second term, hydration. The hydration process is exothermic. Hydration process is exothermic. When the gaseous ions of sodium and chloride are immersed now in water, are now attracted to the molecules of water, the reaction is exothermic. The energy released is called hydration energy, and it is denoted by delta H, hyd. So now the sodium ions in gaseous form, the chloride ion in gaseous form become immersed in water, and they become surrounded by several water molecules, and they become hydrated. So once they become hydrated, they change to aqueous, because now water they dissolve, forming an aqueous solution, and now the ions become aqueous. So the enthalpy change of hydration is -771 for sodium chloride. when sodium chloride dissolves in water, the enthalpy of hydration is negative 777 because hydration process is exothermic. Therefore, hydration energy is the energy that occurs when 1 mole of a gaseous ions become hydrated. Now we have done 2 terms. The third one is heat of solution. Now what is heat of solution? This is the overall enthalpy change that occurs when 1 mole of a solute is dissolved in water. It is denoted by delta H solution, SLN. So heat of solution, it is the overall enthalpy change that occurs when 1 mole of a solute is dissolved in water. It is denoted by delta H SLN. That is heat of solution. Now the next one we want to look at now, what is the relations between the 3 of them? Now we are looking at the relationship between now the heat of solution, hydration, and lattice energy. Now since we are dissolving an ionic compound in water, we have already dissolved that, to form a solution. We are forming a solution in aqueous state. That is the final product. We add reverse lattice energy. Reverse lattice energy, remember, it is bond breaking. Which is a positive, and hydration energy, which is negative. Therefore, the relationship between the 3 is that heat of solution is equal to lattice energy plus hydration energy. But always remember, hydration energy is negative, the reaction is exothermic, and the lattice energy used here, which is the bond breaking, is endothermic, positive, negative.